Okay, 15. Okay. Short answer. On the short answer questions on the final, if you read the directions, they are going to be worth a sizable amount of points, so I would definitely show work. And I will give as much. They usually give me specifically how I can award partial credit, so I'll give as much as I can. So if I look at 15, we've seen one similar to this before. 1,600 centimeters or 600 centimeters of material is available to construct a box that has a square front and back sides and has an open top. It has a square front
and
back sides.
I think they're trying to get us to say it's a cube, but it's...
Find the largest possible volume in the box that can be constructed. Please justify that answer and is the largest possible.
So I don't
Okay, it has a square front. Oh. Square front and back.
It's just sides.
Yeah, I don't know.
So are they saying it's a rectangle or a cube?
No, it's a rectangular prism with square faces and three.
But why it has the wording is weird.
It doesn't say that. It's
Right?
back
But it
sides.
doesn't say...
It has a square front and back.
Front and back sides. Yeah, sides.
Back and side.
It should just
I think it means like back.
okay. Yes.
Sides.
So it has a square front and back sides. Front and back.
I can't
Yes.
believe it.
It's weird, but yes. So here's my X. It has a square front, so I'm going to label X and X like we talked about yesterday. It has the sides, and then the back is also a square. It doesn't say the sides are squares, so we are going to assume they're not squares. Otherwise, they would have told you.
Would they though?
Yes.
I feel like they might trick us.
So I'm going to label the sides as Y. Because the front and the back are the squares, so the length or the width or whatever we'll label as Y. Let's go ahead. We want the largest possible. So this is going to be what type of problem? Optimization. Probably not. Optimization. Maximum. And I want to justify. We talked yesterday about how the two ways to justify a max or min. So optimization, we usually have two formulas we work with. First information they give me is 600 centimeters squared of material is available to construct a box. So that 600 centimeters square represents the what? No.
Surface area.
Surface area. First of all, look at how it's labeled, a centimeter squared. So I know it's area, and I'm constructing a box, so it's going to be all of your sides, the area of all your sides. So that will be the surface area. It doesn't have a front, it doesn't have an open top or anything like, oh, it does have an open up. Has an open top. So make sure you see if it has an open top or not, because that's going to change some things. Surface area is the area of all the sides. So formula for that. So x squared is the front and the back, so that's going to be 2x squared. It's an open top.
So 3xy.
3xy. So that's the formula. Like I said yesterday, usually with optimization, you have a formula you're going to use to solve and plug in, and then you have the formula you're actually optimizing and taking the derivative of. This is not the one I'm taking the derivative of. What formula am I going to be taking the derivative of? The volume. I want the largest possible volume. So that is going to be the one I take the derivative of. So the volume formula for this is length times width times height, so that's going to be x squared y. The open top does not affect the volume. It affects the surface area because you have one less side to worry about, but it does not affect the volume. So again, strategy for this one is kind of similar. All optimization usually kind of have the same pattern at least. Not saying it's super easy, but you kind of have at least.
Except the first equation you go to y.
Yeah, so you want to use this equation, solve it for x or y, and then be able to plug it in. Because before I take the derivative of velocity, I want to have a single variable. Easiest one to solve this surface area formula for?
Y.
Yes, because there's multiple x's. So we're going to solve this for y. So we're going to subtract 2x squared. So 600 minus 2x squared equals 3xy divided by 3x. And you can actually divide it out, which I'm going to do because I'm going to end up plugging it in and then taking the derivative. So that will give me 200 x to the negative first, because it will be 200 over x. So I'm going to make it 200 x to the negative first minus 2/3 x equals y. And I only divided it out so I'd have a nice polynomial to plug in. So we're going to take that and plug it in for y. So x squared times 200 x to the negative first minus 2/3 x. Again, before I start trying to optimize and take the derivative and set equal to 0, I want it into a single variable. So usually they will give you a formula where you can solve for one and plug it in. They all kind of follow that pattern. Before I take the derivative of this,
Let's distribute it.
yes, so that's going to give me, if I distribute x squared, 200x. That works out nicely. When you distribute, you add the exponent. So that's 200x minus 2/3 x cubed. Not as super messy. Like I said before, the nice thing about not being able to use calculator is you're usually going to work out decently nice. Watch the final just be terrible. But first derivative,
200.
okay, minus 2x squared. So negative 2/3 x cubed, the 3's cancel, reduce your exponent by 1. Set it equal to 0. Solve this for x. And we get x to be 10. So 100 equal x squared, square root, technically plus or minus, but x represents the side length, so I cannot have a negative. So I get x to be 10. We cannot assume that this is a maximum. We have to check it, and I gave you two options yesterday. One way to check that 10 is a maximum.
Interval.
Yes, check your interval. So if I think about my domain for x, it's going to be 0 to technically,
10.
no, technically x could be any value between 0 and 600. I mean, whatever. It's not really going to matter. Technically, you can't have over 600. You could put infinity, and it's not really going to make a difference. But so here's my domain. We're going to split the interval up. Put at 10, your critical point. And if we do the interval method, we plug it into the first derivative, and we want to check to see, in order for 10 to be a max, I'm going to have to go from what to what? Increasing to decreasing. So if I plug in 1 into the first derivative, which is right here, I get back a positive, increasing. If I plug in 11 to the first derivative, I get back a negative, decreasing. So that is good. Another option,
Second derivative test for Horizon not working.
yes, second derivative tests.
It says I have it, but
Yeah. Thank God we don't need to worry about that. Second derivative test. Take the second derivative, plug in your critical point. So if your second derivative, when you plug in your critical point, is positive, it's a minimum. If it's negative, it's a maximum. Second derivative will be negative 4x. So I like the second derivative test if it's easy to take the second derivative. This one is. Plug in 10. That is less than 0. So we have a max. Therefore, max. Those little 3 dots mean therefore. So since it's less than 0, therefore it's a max.
yeah, I can't get my Horizon.
Did I answer the question?
No.
No, do not forget to do this. I did. Was it yesterday or the day before? I forgot to do it.
Yeah.
Find the largest possible volume. I know an x value of 10 will give me a maximum. I need to find the volume. So I'm going to plug 10 back into the volume formula. Now, yesterday or the day before, I found x and then plugged it in, or I found y and then plugged it into this formula. It doesn't matter which one you use. I would go ahead and just use the one that's all in terms of x, so you don't have to find y. But you could find y and then plug it in. Either way is fine. Plug in 10, which will give you 2,000, 20,000, 2,000. 2,000. 10 cubed is 1,000. So 2,000 over 3, right? What do you think about right? So that's 6,000 over 3. And I get common denominators. So 4,000 over 3. They would not want you to leave it like that. Oh, actually, that's how they have their answer. So, I mean, you would get decimal, but whatever.
Would you get
And label it cubed. Find the largest volume.
If we would have got a decimal there, would you take points off?
I would not.
I forget. If you checked it and you know you're supposed to get a max, you get like a min, vice versa.
You did something wrong.
So it should come out.
Usually, yes.
That's what
I got 10.
If it comes out and you're like, if you have two critical points and you check one and it comes out wrong, then try the other one. If you only get one, it should work, I would say. Oh, you just put the fan back there. I was like this. Okay. Questions on that? Okay, last one we're going to look at 16.
Hold on, hey,
Yes.
last one. When you plug that back in to
Yes.
find your dimensions, you're solving for y, aren't you? You have to solve for y to know what your dimensions are.
You can either solve for y and plug it into this volume equation, or use the volume equation that's all in terms of x. So a couple of days ago I solved for y and then plugged it in. You just add an extra step. So I would just use the one that's already in terms of x. You should get the same answer either way.
Yeah.
You should.
Well, what if I get the same answer I've been getting, this different answer that you've been getting?
Here? So you found y to be, I don't know. It should work out. I can look at it later, but it should.
Well, I got y to be
I don't know what y is. I didn't find y.
over x minus 2/3 x. Right? That's what you have.
Yes.
So your y equals.
You made a little mistake somewhere, probably. This is why I just plug in x, because then you don't run the risk of making an error.
Yeah, but I got the same, but like the thing is though, my y equals the same thing your x does, or your y does, and I plug it in and get the same. So shouldn't I still get the same answer back?
Possibly. I don't know. I'll look at it at the end. Remind me. I'll look at it.
No.
Okay. But it's not a cube, so not necessarily. X and y isn't necessarily the same.
Yeah, but what I'm saying is my y is equal. I found y to be the same thing you did.
I didn't find it to be the same thing as x.
No, as y.
I didn't find y.
Yeah, you had to say you solved it in the beginning. You solved y equal to whatever.
Here.
Right, so if I plug in an x, I should get a y value.
Yes, and then you can plug it in this one if you want to.
Right, to get my dimensions.
Right. So you found y to be 20.
100 over 30. And so I just need to plug that back in, right?
20 minus 20/3. So 40/3 for y. So if you plug in 40/3, x is 10, so it's 100 times 40/3. 4,000.
So, wait, hold on. So, okay, that's fine. Okay.
Yeah. So you could find y and then whatever. Either way, you should be fine. Okay, 16. This is a fun one. Two squirrels named Alice and Bob start running from the same tree. We've done one like this before. Not with squirrels, but...
Wait, why did they give the names?
Why not?
to make you laugh on your final. I don't know.
Oh god.
Because by 16 you probably hate your life. Two squirrels named Alice and Bob start running from the same tree. Alice heading north and Bob heading west. Moments later, Alice is 30 feet north of the tree and Bob is 40 west of the tree. At that instant, Alice has a speed of 20 feet per second heading north. Bob has a speed of 15 feet per second heading west. How fast is the distance between them changing at that instant? Okay. Don't let it drive you nuts. Okay.
Okay, no, seriously though.
We have done ones like this, but they were boring and had ships instead of squirrels, and planes, but it's the same idea. Okay, so let's draw a picture. Let's draw a picture. Okay, so they're starting from the same tree. So here's my tree. Alice is heading north. So here's Alice. Bob is heading west. Dang it, I'm running out of space. Through the round. There. So Alice is heading north. Bob is heading west. Moments later, Alice is 30 feet north of the tree, and Bob is 40 feet west of the tree. So let's, before I start labeling, here's my right triangle. And let's just label X and Y, just because that's kind of what we tend to label them. So we know at some specific instant, what is 30? Y. So we know at some instant. Now, that is changing. That is not a constant. So we cannot plug the 30 in until after the derivative. Same with Bob is 40 feet west of the tree. So what would be 40? X. I don't know. Whatever. Don't overthink this. So those are not constants because they are changing. So you cannot plug them in until after the derivative. At that instant, Alice has a speed of 20 feet per second heading north, and Bob has a speed of 15 feet per second heading west. When they give me speeds are what? Derivative. They are rates. So what will be 20? What will be 20? dy over dt. That is the speed that Alice is running north. So that is the change in y. dy over dt is 20. dx dt is 15. They are running away from the tree. So those are both positive because they are increasing. The distance is increasing because they're running away from the tree.
Why do you think they're running away from the tree?
I don't know. I want to know how fast is the distance between them changing. So here's Bob, here's Alice. The distance between them would be your C or H or whatever you label it. So I want to know what? dc dt. I want to know how fast is the distance, how fast, speed, rate. So dc dt, the change of c in respect to time is what I'm looking for. Okay, first thought on this.
X squared plus y squared. Well, my first thought is that Alice must
I
have
don't
got
care anymore.
slow at first, but
Sorry, I
Bob got a
asked.
sprint, and when they got to this point, they're like, Bob was like, whoa, I gotta slow down.
Yes.
And Alice
He was feeling
pick it
nice.
up.
They were probably throwing.
I really
You can't trump my first joke, so it's not even worth it.
About the nuts?
Yes.
I liked it.
It's funny. Okay, so yes, so we have things labeled. We have a picture. Related rate question. We want to come up with an equation, right? Kind of putting all this stuff together. Yes, as we've seen before, this is a right triangle. I know nothing about the angles, so this is not going to be SOHCAHTOA because I don't know anything about angles, and they give me information about all three sides. So this is going to be Pythagorean theorem. So x squared plus y squared equals c squared. Let's take the derivative and see what I need to plug in so that I only have dc dt left. Derivative is 2x dx dt. You've seen some like this before. 2y dy dt. And 2c dc dt.
DC.
Can't trump my joke. Yes. So let's start plugging stuff in and see what I need to find. X is 40. Dx dt is 15.
40 because they're that away.
Y is 30. Dy dt is 20. And you will notice I want to know dc dt, so that's going to be the only thing left. But I know nothing about c. Had some like this. Correct. So I want to know what is the hypotenuse, what is c at the instant when x is 40 and y is 30. So we can use Pythagorean theorem to find what the distance is, c, when x is 40 and y is 30 at that instant. So 1600 plus 900 c squared. So 25, again, no calculator means it's probably going to work out decently well. So square root of 2500. 50? Yeah. It's also, if you didn't notice, it's a 3, 4, 5 triangle. So again, when you're looking at right triangles, we saw this a couple days ago. This is a 3, 4, 5. So one leg is 3, the other leg is 4, so our hypotenuse would be 5. Intervals of 10, so factors of 10. So C is 50. Okay. Let's work on solving this. 215, go back to like your middle school days. Choose the order you multiply. So I would do 21530 times 40, 1200, plus 6120. Nope, 1200 equals 100 dc dt. 2400 equals 100 dc dt. Divided by 100, 24. Now your number should always kind of make sense-ish. You're not going to get like 800 and something when the other rates are 20 and 15. So 24 makes sense. Label it feet per second, or write out feet per second. Either way is fine. Okay. Questions? Okay. Let's sit on that one.
Yeah, my Verizon's not working at all.
Again, I will be collecting these, so make sure you keep hold of them.
So do we not need to know how to do 17?
No, not worrying about it.
The E thing.
You don't think it'll be...
I'm not worrying about it.
Okay. If you're not worried about it, then I'm not worried about it.
There's other things that I want to get to earlier.
I hope there's another Schwab in here.
If I return it. They're starting to have to pay road taxes though, because they're trying to somebody's car.
If there's a long time, returning this accident, it's like you.
Well, you know what? Once your hands are in, you also pay taxes, just like mine have everything. And if you don't keep taxes, see that? That's not actually taxes. Tax. Like everybody takes half back. And it's online. Nice estate tax credit.
Okay.
That's what you got to look at.
Okay. Let's look at these. We'll see how many more we can get through. I don't know how many more practice we can do, but. Okay. Multiple choice. Let's get started. Number 1. Okay, so limit, piecewise function. What is the limit as x approaches 1 of f of x? So thing with this one, remember, when I talk about limits, it is the value as x is approaching 1, not when x is 1. So which one can I cross off?
The middle one.
A. Cannot be A, it cannot be 1, because the function is equal to 1 when x is 1. Basic idea of a limit is it's x as x is approaching 1. So it's never equal when x is equal to 1. So we cross off A right at that. So to look at my limit, first thing I notice about the limit is what do you mean?
It's going to 1.
It's approaching 1. Is it more specific than that?
So it has to be x squared minus 1.
It's not
It's 0.
It's not approaching from a specific side. So I have to correct. So if I would have a little plus here from the right, then I would have checked the top one. If I would have had a little minus from the left, then I would have used the bottom one. Since it does not specify, I need to check the limit from the left and from the right. And what do I know about both of those? They have to be the same. If from the left and from the right were not the same, then it would be C. It does not exist. So left and right both have to be the same. So now, it's not bad once you get that idea down. From the left, you're plugging it into the bottom one, because that's when x values are less than 1. So 1 squared minus 1, 0. When I come from the right, plug in 1. ln of 1, again, look at the graph. We talked about it yesterday. This is ln. So when x is 1, it's 0. So your answer is B. So the key for that one is when it doesn't specify left or right, you have to check that left and the right are the same. Otherwise, it does not exist.
What's ln of 2? Is that like a number we need to know?
ln of where?
This is just not related to this.
ln of
1 is 0, but like ln of 2, do
no,
we need to know that number?
no. You would just leave it as ln of 2. Unless if you take the derivative of it, it's just 0, but because it's just the number. But okay, let's look at 2. We've had one like this before. H of 3 is 5. G of 3 is 8. Let f of x equals g of x, h of x. What is f prime of 3 in terms of g prime of 3 and h prime of 3?
We'll have to take in right there.
Yep.
Yeah.
What are they looking for?
We're looking for f prime of 3.
Yes, they're looking for f prime of 3. First thing I'm going to have to find f prime, and then plug in 3. So as I look at finding f prime, the difficult part with this is not actual functions. They just have it labeled in function notation, g of x and h of x. I'm going to have to use the
Chain rule, not product rule.
product rule. So first times the derivative of the second, so g of x times h prime of x plus the second h prime of x times the derivative of the first, g prime of x. Kind of had one that's similar to this a couple days ago. And I want to know f prime of 3, so now we're going to plug in 3 for x. So g of 3, h prime of 3, h of 3, g prime of 3. How can I go further?
Yes. You know what h of x, well, you know h of 3 and
Yeah.
g of 3.
So g of 3 is 8, so that's h prime of 3. And it says, what is f of f in terms of g prime of 3, h prime of 3? In terms of mean those are going to be left in there. Like when I say a function in terms of x, x was left in there. G prime of 3, or sorry, h of 3 is 5. and that is all you can do. You cannot combine them because they're not the same term. So that is, yes. Okay, 3. Again, seen these a lot. Concavity increasing, decreasing. So hopefully we hit it over and over again. F of x equals ln of x squared plus 1. Which of the following intervals describes all the points where f is concave up? Second derivative. Concavity is second derivative. Set equal to 0 or where it's undefined. So we need to find inflection points and then split up the domain. So let's go ahead and find a domain for this one because that's what we're going to use to split up. It's ln. So I know it always has to be, yeah, so my domain would basically will be 0 to infinity. We'll just use that for now. There's no way I'm going to get negative numbers back.
You can't take the ln of a negative number?
No. Think about the graph.
Oh, it's like that.
Yeah, so there's an asymptote, so it's to the right. And plugging any positive number will never get you back negative because it's x squared plus 1. So that's my domain. Let's go ahead and take the second derivative, find some inflection points, if any. Oh, well, this is not f prime yet, just f. So f of x is ln of x squared plus 1. Derivative of this will be,
1 over x squared plus 1?
yep, chain rule, single chain rule. 1 over x squared plus 1, sorry to disappoint you. 1 over x squared plus 1 times the derivative of 2x. So the derivative of ln is 1 over the inside part, and then times the derivative of the inside part. So that is 2x over x squared plus 1. That's the first derivative.
Quotient rule.
Correct. I want concavity, so I need to find the second derivative. So we are going to have to use a quotient rule. There's no way to turn this into you can't divide. There's not a monomial on the bottom, so I can't divide, I can't factor, or cancel out. So you're just going to have to do quotient. So low, x squared plus 1, d high, 2. So low d high minus high, 2x, d low, 2x, all over square of what's below, x plus 1 squared. We don't usually factor out or FOIL the bottom. Just leave it like that. Simplify the top. 2x squared plus 2 minus 4x squared over x squared plus 1 squared becomes negative 2x squared plus 2 over x squared plus 1 squared. This one will actually kind of work out nicely, but no, it's close, yes. I almost thought I could factor out a negative 2, but then that would make this x squared minus 1. So you cannot cancel that out. Or
But then it works out nicely when you just set it equal to 0.
oh, yeah. Okay, so here's the simplified second derivative, which I'm going to kind of star, because that's what I'm going to plug in to check concavity. Almost could factor the top and cancel out, but we can't. So when I'm looking for inflection points, it's where the second derivative is equal to 0 or undefined. So when I take that and set it equal to 0, I'm only worried about the top. Anytime I take a fraction equal to 0, I only worry about where the top is 0. Subtract 2, so negative 2 equals negative 2x squared divided by negative 2. 1 is x squared. So x is plus or minus 1. I could have plus or minus. Actually, I cannot have negative 1 because
You can.
Undefined.
it's not part of the domain.
Yeah, but you can plug it into negative x so you get a positive number back. You'll always get a positive number back.
So is my domain.
I think it's all real.
Yeah. So yeah, so my domain is actually all reals. because I'm squaring it. So even if I plug in negative values, you will still always get back positive. So yes, it is technically all reals. Easy mistake. So those are my two critical inflection points. We also have to look at where the second derivative is undefined. So make sure you check, especially if you have a fraction like this. Is there any x value that I can plug in that will give me 0 in the denominator? Nothing squared will give you -1. So there's no inflection points from the first or second derivative being undefined. So split up your integral. Negative infinity to -1, -1 to 1, and 1 to infinity. We are checking concavity, so we plug it into the second derivative. Plug in -2. Here's the reduce. Make sure you include your denominator in the second derivative, not just the one you set equal to 0, the one that still has the fraction part. -2 will give me -8 plus 2, so negative over, the bottom will always be positive because I'm squaring whatever answer I get. So negative, concave down. If I plug in 0, positive over positive, so positive concave up. Plug in 2, same as -2 because I'm squaring it. So -8, negative over positive, so negative concave down. -1 to 1. I think you could have. You've seen it a lot before. At least could take edge cake at you leaving. Yeah.
I would have forgotten to.
Who else? Is it just you in here? Yes. Good luck. Run fast. And jump over things. Do you hurdle? Okay. Hopefully he's not. If he is, then the rest of this will be posted. Okay. So we'll get a couple more. Okay. For which value of x does f of x equals x to the 1 over x squared have a global maximum? I believe global, it's weird wording, I believe global is the same as absolute.
So doesn't that mean we need 0?
You need your endpoint.
Yeah, that's what I said. It must mean.
Let's see.
Which makes no sense.
Okay, let's see.
Why is it different? Same color. I guess we need
Yes, okay. So let's see. Let's just start to see. Okay. So let's go ahead and whenever we talk about max or mins, we're looking for critical points. I do not have endpoints on this, so we're just going to plug along and see where we get. So f prime this is, yes, this is an exponential function.
Natural log both sides.
That's what I would do. So I'm going to try logarithmic differentiation because I only know how to take the derivatives of exponential functions if the base is e or the base is another constant, not if it's x, like in this case. So I'm going to try, first of all, it's y equals. I'm going to start with logarithmic, like we have talked about before, and see where that gets me. So ln of y equals ln of x to the 1 over x squared power. Ln will allow me to do what?
Bring that out front.
Bring the 1 over x squared out front, because it's an exponent. Derivative, left side will be what? 1 over y, y prime. So you take the derivative of ln of y, which is 1 over y, put y prime there, equals 1 over x squared first. So 1 over x squared times the derivative of the second, which is 1 over x, plus the second ln of x times the derivative of the first. So that is x to the negative second. So it's going to be negative 2 over x to the third, right? Because x, that becomes x to the negative second, so negative 2 out front. Reduce your exponent by 1, negative 3. Move to the bottom. Let's see. Let's simplify a little bit. So it's going to give me 1 over x cubed minus 2 over x cubed ln of x. Actually, I can combine these. I can throw the ln of x on the top, so technically that would give me 1 minus 2 ln of x over x cubed, right? Multiply by y, so plug y, so that will give me y prime equals 1 over this. I don't like that.
You're gonna get E at some point.
Because I took and I multiplied y to both sides.
But you plugged Y back in what Y equals.
Yes, I got it in terms of x.
Sure. Y equals X.
Where? Oh, yeah, I multiply by y, not 1 over y, so this should just be this. Sorry.
Set the top equal to 0.
Yeah, but I have that. Yes. I'm making this hard. I'm wondering if I'm making it harder than it needs to be. So, if I set the top equal to 0, you're going to have 0 equals x to the 1 over x squared power times 1 minus 2 ln of x. So I'm kind of squishing it all together because that's my top part. Is there? Okay, let's use common sense.
Plug and chug, see if we can just like right now. Can't be 0. Cannot be 0.
I'm gonna have to come back on this one. We'll have to think about this one. If nothing else, we practice logarithmic differentiation. The answer is E. Square root of E.
Well, don't tell me that.
Well, and right, but we'll come back to that. Remind me to come back to that.
E squared, e to the 4th, 1 over e to the 4th.
Wait, is that the one you have to do like the power that's not equal to a constant?
I'll look. I'll come back to that.
Derivative e squared is
Okay, let's look at 5. This will be the last one we do today. Okay, here's the integral. Now the hint. So my first thought on this, if I did not have the hint, if they did not give you the hint, the first thought would be what?
just different, or just take the integral of it.
You can't though, because it's a composite function.
What do you mean? Can you just use u sub?
Oh, well, yeah, you could do u sub. So my first thought, if they didn't give me the hint, was to do u sub. So du is negative 2x dx. But as I try to plug in, the issue I'm going to have is what? This 2x here. I don't have an extra x anywhere outside the square root. No, because you can only do it to a constant.
To a constant.
If it was just a -2, yes, but there's an x,
Oh,
so you
do
can't.
that with.
Correct. So then their hint, we've had some like this before. Their hint is helpful because it says interpret the integral as the area under the curve, which we've done before. So if I take this function, and all I'm doing is I'm just saying, okay, that square root of 1 minus x is my function, so I'm going to set it equal to y. We've done something like this before. There's that nasty piecewise one on the study guide. We had one on the notes like this. I'm going to have to do what to both sides? Square. So now we see that this is a circle. Add x squared, so x squared plus y squared equals 1. No. As I look at this, let's graph this. Now, this is, you have to look back at where I set it equal to y. Y is equal to a square root, so it's only going to be a half circle above the x-axis. So my center is what?
0, 0.
My radius is
1.
1. So it's a half circle like this. So that was the key for this one. The hint was helpful. So you would have started U sub probably. You would have had that random x. So then you would have went back and we did something like this where you set it equal to y. Look at it as a half semicircle. The integral is the area under the curve, but I'm only between what x values? Look at your interval.
0, 1.
0 to 1. So I'm actually only taking half of a half circle. So the formula for a circle is pi r squared, but I'm only looking at this quarter of it. So it's going to be divided by 4, or 1/4 pi r squared, or half a pi r squared and then take half of that, whatever you want to think about. So your radius is 1, so it's just going to be pi over 4. So this is a completely brand new. We did some like this, but yeah. Next one's average value. We did one like it a couple days ago, but
I mean, at least you had a chance to just guess.
yes.
You get whole.
Okay.
Whole,
Any questions on the review packet?
The heck is 10?
On this one?